Okay, so just at the top here, plug, they were in their last class, but they weren't able to come to this class. But a plug for Corn Hacks, which this year is March 1st and 2nd, so it's coming up in a few weeks here. Corn Hacks is an annual hackathon. So it's a 24-hour hackathon where they provide food. You don't have to go 24 hours, but you form a team. Apparently the theme this year is futuristic. I don't know what that means as far as the expectations, but you can build whatever you want, right? And even if you're just starting out, you're a freshman. Most people in here are freshmen. Don't think that you can't compete in Corn Hacks, especially the honor section here. You can take it as an opportunity, even if you're not going to compete, as in like expecting to win one of the prizes, the top 3 prizes. You can still take this as an opportunity to form a team, have some fun, and learn some sort of new technology. Yeah, I don't know. Hopefully it opens back up now too. But anyway, you could go ahead and on the live stream if you want, you can go ahead and go with the QR codes here. Otherwise, it's at unlcornhacks.com, right? And they've recently updated the website, so they should have some new information here. I think March, where is it? March 1st. There we go. Corn Hacks will start on Saturday, March 1st, and will continue through Sunday, March 2nd, with an optional info session on that Friday before. This year, it's probably going to be in the new Kiewit Center over in engineering. And they have food, they have prizes and T-shirts. Last year, the prizes proved to be very, very popular. Were Legos, so we're doing more Legos this year. Right? All right. So, any questions on Corn Hacks? No. All right. I highly encourage you to take advantage of the opportunity. Right. All right. So going back to object-oriented programming here. We already went through the isotope demo. We'll actually go back and do a few more things with it. But I wanted to start talking more formally about object-oriented programming in the context of Java, of course. Different languages do object-oriented programming a little bit differently. For example, JavaScript was never really an object-oriented program. I mean, it was kind of an object-oriented programming language, but when it started out, it did not have classes. It was a classless object-oriented programming language where you would create objects ex nihilo, out of nothing, is that what that means. But eventually they added classes. Why? Because that's the familiar object-oriented programming approach in most programming languages. And so pretty much anything is going to have classes nowadays. Python added classes because of demand. PHP added classes later on because of demand. And everybody wants to do their OOP using classes. For Java, that simply means that everything is a class or belongs to a class, right? It allows you to model, classes allow you to model real-world objects, or sometimes we call them entities. More formally, an object is actually 3 things, right? It's identity, state, and behavior. We'll come back to identity here in a second, but state should be pretty straightforward. When you create an object like an isotope, you give it member variables. Sometimes those are called elements, attributes, data, fields. We're going to call them member variables. Okay. Also, when you create a structure in C, a struct, you also have member variables there. Right? So it's kind of an object, but it's not an actual full object because structs do not have behavior. Behavior is the functionality that acts on that object's state or data, what the object does or what services it provides. In other words, what methods it has. Okay. Coming back over here to the isotope class as an example, we did have a constructor here. We did have getters, right? But that's not really behavior, right? That's just boilerplate stuff. The real behavior came with decay, right? The decay where it actually behaved, and we sent it a signal to say, decay yourself by a period of time. And it did it, right? It did all of the details of that were encapsulated in this function here, right? It's behavior, okay? What about identity? Identity we kind of hinted at before. Let me go back to our book demonstration here. No, that's not it. This one over here. The book demo, where is it? Right. There it is. So let me run this again. And do you remember our first iteration of this? Haruki Murakami, or maybe it was Wizard of Oz guy, Baum, Frank L. Baum. Right? Haruki Murakami here has 3 books. In our first iteration, there were actually 3 Haruki Murakamis, 1 for each book. Do you remember that mistake? The solution to that was to go into the author class, or the person class, excuse me, that represents an author, and to add 2 methods, the hash code and the equals method. That's what defines behavior, or that's what defines identity in Java. That this person is equal to that person if either they're the same thing in memory, or they have the same first name and the same last name between them. Oops. There we go. By the way, if you ever accidentally click on something and it takes you where you don't want to be, there's a back button over here. Just have to... there should be a back button. Where is it? Oh, well. There used to be a back... maybe it's a different perspective. Package Explorer. Anyway. Something else here that is interesting. I've always had this enabled, but maybe it's not enabled by default, right? Say that you've got multiple projects here, which I do, that have 2 person classes here. And I go to edit one. Here's another person class. Oh, no. Where is it? Here's another person class because it was from a different section. There. Now I've got 2 person classes open. And I start editing this one when I really meant to edit this one over here. Right? If you make sure to enable this, then whatever you focus on, do you see that? Back and forth. It focuses on the appropriate class and the Package Explorer over there. If I'm editing this one over here, I know that I'm editing this file. But if I edit this one over here, now it snaps to this one and I know that I'm editing this one right here. Right? Undo, undo. Right? Without that enabled, then I could go ahead and, focus on this one over here, but start editing this one over here, and now the focus is off. Right? So what is this called anyway? A link with editor. So that whatever you're focused on over here and editing, it refocuses on the appropriate file, but only if it is enabled. Right? Back and forth. Just another helpful hint there to use your IDE to its fullest. All right, so to be more formal about this, again, Java, the identity is determined by the overloading of or implementing the equals in the hash code method. Don't worry about the details of how to go about doing that. Just simply go up to, let's go to book here, go up to source and generate equals in hash code. And it's already there, apparently. Yeah, it already contains one, so it's not going to do it again. But if I got rid of it, then it would basically regenerate these 2 here. Right? So just auto-generate it. For now, just auto-generate them. Okay. Communication between objects is done using something called message sending. This is just a fancy term. Right? Don't worry about the fancy term. All you're doing is you're calling or invoking the functions on the object. Over here in that, now I want to get back into the right one. Here we go. Assignment H, there we go. There's the isotope demo. When I called decay, isotope.decay, I was invoking a function, but conceptually I was sending a message to this isotope to decay yourself by a year. Right? I was telling it to do what to do, not how to do it. The decay function is responsible for how to do it. Right? So basically, calling a function is telling an object what to do, not how to do it. That's the object's responsibility. Right? Remember that mantra. If it's an X thing, it belongs in the X class. If it's a book thing, it belongs in the book class. If it's an isotope thing, it belongs in the isotope class. Right? Communication is facilitated through what's called an interface. And an interface is just public methods that are available. If I had made this a private method, of course it would have broken the code over here because you can't see that method anymore. But it's no longer part of the interface of that object. And an interface is because you're interfacing, you're interacting with the object. Right? That's why it's called that. That's not to say that private methods don't have their usage. You can still have private methods, but they are not part of the interface, okay? And private methods do have their use. Private methods are useful. So don't just think, nope, I've got to make all my methods public. There are use cases for private methods, right? Another thing to realize is that objects are constructed rather than assigned. When you're talking about built-in types like integers, int a is equal to 42, you're just assigning the value 42. You never actually specified how 42, base 10, gets translated into a binary, then gets stored into this variable in memory somewhere. That is the compiler's job. That is the assembly language job. That is the Metal's job, right? That's not our job. But now it is our job because we have to specify how objects actually get constructed using a constructor, right? And in Java, constructor methods are named after the class, right? In this case, isotope. That makes it a constructor. They have no return value. Right? There is no void. There is no isotope right here. And they can take any number of parameters. In this case, I've got a isotope that takes 3 parameters. Right? If you do not define a constructor, a default value constructor will be provided for you. Let me show you. I can get rid of this. And this code over here will break because you can no longer create that isotope. But I can create an isotope foo is equal to new isotope. Right? There's the default no argument constructor. No argument means that there's nothing passed to it. There are no parameters right here that are being passed to it. That's automatically created for you. Okay? But once you create a constructor, the default constructor goes away now. Now it's no longer compiles. Right? So if you do define a constructor, the default one goes away, but you can always redefine it if you want to. Yeah?
In the constructor there, what is the super for?
That gets into the other pillars. Right? What is everything inherits from object, because everything is an object. It's calling the super constructor. It's super class. That gets into inheritance. We'll talk about that later, probably later next week. Right? So for now, ignore it. It's called implicitly anyway. I don't know why they explicitly do it by default, but whatever. Public isotope. There's the default constructor. What values make sense for name? Oh, its type is a string, but what value of a string would be default? Empty? I don't know. Right. Undefined. And what is undefined in Java? Null. Okay. What about mass? Could I do the same thing with mass? Yeah, I can't do this with mass. Why? Because it's a little d double, right? So you can't assign a null value to the primitive types. You can, however, assign, say, 0.0, or, like you said, -1, right? Or something like that. I'll just go ahead and go with 0 because it can't, it's nothing, right? Or something, I don't know. Half-life as well, it's not a radioactive isotope, it's a stable isotope. Just iron by itself, a non-radioactive isotope of iron is a stable element, right? So, yeah, default values, okay? Again, once you restore it, now both of these are compiling. You can create it with no arguments, you can create it with 3 arguments. If you want to, you could also make it private. Private, no argument constructor. Now, even though it's there, you can't reach it. So I'll go ahead and comment that out. Right? You can do a lot of stuff with this, right? You could also just get rid of it, right? No, there is no sensible defaults. So I'm not going to allow you to even create that anymore, but I'll leave it in there. Right? Okay. So like a lawyer, if you do not provide one will be provided for you. If you do provide one, then that free lawyer goes away, and you can always restore it by saying, no, now I can't afford a lawyer, right? Or something. Right? All right. Common patterns, right? Again, make it so that more specific constructors call more general constructors. I think we've done this before. In other words, don't repeat yourself. We did it with a book class, right? For example, I violated the DRY principle here. Repeated, repeated. How should I have handled that? I should have called this with null, 0.0, and 0.0. That's going to call this other constructor over here. Right? So don't repeat yourself. Right? Also remember the Yagni principle. Yagni. Do you remember Yagni? What does it stand for? You ain't, or you aren't, you're sure, gonna need it. Right. You are not going to need it. Right? They're not. Actually, that's you are not going to need it. So it has to be you ain't gonna need it. Right. So where would this come into play? Right. Basically, you don't over-engineer your objects. Right. I saw a nice TikTok or whatever the short form videos are of this woman talking about over-engineering and in a comical way of saying, you know what, we're going to build a banking system, a store. So we need a store object. Okay, well, what if it's not a physical store? What if it's an online store? So then she gets more and more general until she gets to object, right? Let's go ahead and design an object, right? What does it do now? It's way too abstract, right? Well, no, you ain't going to need that, right? You've now abstracted your way away from anything that you can actually talk about in anything concrete. Here's another example that you might be facing right now. How many folks, so you're probably doing the Python version, which would be just as relevant here, but how many folks are designing their own class to do assignment 1, exercise 3? Okay, hopefully all of the hands should be up. Right. I guess you could do a tuple in a Python, but if you were doing it in Java, hopefully everybody's hand goes up and says, yes, I'm doing that. You have what? A timestamp, latitude, longitude, and elevation. Right? Those middle two, latitude and longitude. Well, gee, that seems like those should be together because it's a location, right? So let me create another location class, right? In which case I've got latitude and longitude over there, and then within that, I use that in my run data class or whatever. And no, yeah, you ain't gonna need that, right? Don't over-engineer. Right? For another example would be that person class that we made. I don't want that anymore. Where's that person class? Oh, first name, last name. Let me go ahead and create a name class. Right? No, you ain't gonna need it. Yagni, right? Anytime, you need the Goldilocks zone, right? We know what the Goldilocks zone is. Not too hot, not too cold, just right. Right? That's what design is all about. Okay. Basically, when you are designing an object, you break an object down into smaller and smaller parts until either one, it is representable by a built-in type, that is string, int, double, right? Or 2. An object already exists for you. Right? So unfortunately there was no person object, so we made it. But certainly there is going to be a, where's my book class there? Right? There was a local date object. We didn't have to do that. Or in the isotope class, there was a period object, right, that represents a period of time. We didn't have to roll our own. We didn't have to design our own. So just break it down until you can get no further, right? And ask yourself, is this problem already solved, right? Generally, objects are composed of other objects or data. An example would be the book class is composed of strings, integers, doubles, and what else was a book? A person instance, right? It owns an instance of the person class, right? That's what's called composition, okay? It's composed of those things, and so we call this stuff composition, right? And we'll come back to that later on when we talk about inheritance. Inheritance can get too deep, in which case you might prefer composition over inheritance, right? Avoid the God anti-pattern, right? So the God anti-pattern is where you have a class should have a single purpose. or a single representation. This gets into something called the solid principles. This is the S of the solid principles. The single responsibility principle. The anti-pattern is the opposite of that. You've got one class that is everything, sees everything, knows everything, right? It is way too powerful. You want to organize your code into smaller classes. A person is not a book. A book is not a person. We separated those out into single responsibilities. Book is responsible for book things. Person is responsible for person things, and isotope is responsible for isotope things. Right? So make sure that you're avoiding that God anti-pattern. Otherwise, there are 4 pillars of object-oriented programming. The first 2 we're going to go through today, and then the rest of them we're going to spend maybe a couple weeks on. The first 2 are super easy because you're already familiar with them. Right? Abstraction is what's called a form of information hiding. Right? So consider math.apps, or so square root. Right? We already looked at this the other day. How does it work? What's the answer? Yeah, who cares, right? Who cares how it works? It just does, right? This is called procedural abstraction. Right? The details are hidden inside the function. We don't have to worry about them. There were like 100 lines of code in there, right? That was probably taking care of a whole bunch of edge cases, corner cases, and IEEE 754 rules for what happens, right? But we don't have to worry about any of that, right? Now, again, consider local date, right? How does it represent a date, right? Or local date time, and that's also a time, right? How does it represent that? In fact, that's more interesting. We already know a local date time. How does it represent a date/time? Right? Is it an ISO 8601 formatted string? Right? Maybe that's what I would suggest that you do in your assignment. That's why we gave you the ISO 8601 standard, so that you could, if you wanted to sort by the date time, you just sort it using a string, right? What about say 3 numbers, right? Or multiple numbers? Several integers, 1 for each field, right? So day, month, year, hour, what else would there be? Minute, second, fractional second, right? All that stuff. Or it could be a single number, a Unix epoch number, right? Again, what's the answer? Who cares, right? Right? The representation is internal to the class. We don't have to worry about it. Just as the implementation is internal to a function, the representation is internal to a class. I am interested though, aren't you? Local, date, time, foo. All right. Let's bring that in, import that, and let's take a look at it. All right. So, oh, there. It splits it up into 2 classes. It uses composition, right? There's a local date, which has a year, month, and a day, and then it has a local time. I wonder what that looks like. Right. And where are your where's your state? There it is. An hour, minute, second, and then a nanosecond, right? So it can represent billionths of a second there. Right? Why? Because that's an 8-bit unsigned integer, and if you're only going to represent up to 24, that's more than enough. Right? This is a full integer because it's 2.147 billion nanoseconds, which would be billionths of a second. Right? Likewise, over here with a local date. Good question on this. I have no idea. They could have gotten away with bytes on those 2 as well, because it's 1 through 31 or 1 through 7, but they went with shorts. Year, certainly, because you want to represent out to year 2 billion, 2 billion AD, after which point it breaks, of course. Right? Don't worry, none of your run data was 2 billion years in the future. Right? I wouldn't have done that to you. It's all actually real data anyway, right? So it can't be. Right? That's all Strava data. You can pull your own Strava data. Right? Oh, reminder, We have a run with School of Computing this afternoon at 2 o'clock if you want to come. Right? We'll do a 5K. One of those run with School of Computing is actually the test case in the grader. Right? All right, so the representation is internal to the class. Right? Abstraction allows you to reason about an object without actually knowing how it works or is represented. Right? Awesome. We've also seen encapsulation. Remember that encapsulation, when we were talking about it with C, it's three things. It's the grouping of data into one logical unit. Right? We're grouping these three things into one class. It is the protection of that data from the outside world. Right? We are making them private, and then we have no setters here. Did I have a setter? No setters here. So we're protecting it from the outside world. And then finally, we're grouping methods or behavior that act on that data. Should I have located this decay method outside of this class? Nope. What would it look like if I did? What if I had made it, yeah, we want to put it into a function, a public static decay method. Static void decay method, right? There is no this anymore. What would I have to do? I would now have to take an isotope, iso, right, as well as a period, and then I would have to say isotope dot set mass to that mass, iso dot get mass, right? And then I'd have to say iso dot get half-life over here, right? And I'm not even going to complete it anymore, but that's breaking encapsulation. Locating book stuff outside the book class, locating isotope stuff outside the isotope class, don't do that. You're breaking encapsulation. Right? Let me undo that. Undo. There we go. Restore. Oh, by the way, another trick that came up in a lab this week, somebody said, I lost everything, right? Because I'm not using get. So slap on the wrist, what should you be doing? Use get. Failing that, they had the file, but they had erased code and they couldn't recover it. Right-click, compare with, there it is, compare with local history. This is not a Git repository, but you have I have local history going back here to 2 days ago, right? Pretty much anytime you save or something like that, it will take a snapshot of this code so that what did this code look like 2 days ago? Double click it and you'll see, oh, we only started out with the state over here. And then eventually we filled in all the rest of this. Right? But it's comparing, the only thing that survives here is apparently those 3 lines of code there. Right? That doesn't actually change your code. It just gives you access to an older version of it that you can then copy, paste, and do whatever you want with. Right? What did it look like? That's the 5th. The 5th started on the 7th. So what did it look like on the 5th? At the end of class, 2 days ago, it looked more like that, like what we have right now, right? But that is a way to recover, right? But remember, slap on the wrist first. Use get, period, right? Okay. All right. So generally, what you should do for encapsulation is that all member variables should be private to protect them, unless you have a very good reason. And it's all got to be capitalized too, because otherwise it's not a very good reason to do otherwise, right? You can make as many constructors as you want to make them flexible, to make your uses flexible. You can, or you should, avoid setter functions, right? In other words, you should prefer immutable objects that cannot be changed, okay? So there are ways around that, though. Better patterns. Right? Say copy constructors. Okay? And that's what I'm going to show you here, and then we'll probably call it early because I need to get over for a meeting. All right? But otherwise, let's go ahead and show you what I mean over here. Let's go back to the isotope demo. Oops, come on. Oh, I made it private. No, it's right there, save. All right? And why are you complaining about decay? Is undefined. Oh, you know what? I was probably editing the wrong isotope. Let's go ahead and get rid of all this stuff. And This is the H section, so let's go ahead and grab that isotope and that isotope demo. There we go. All right, okay, it's fine. There's decay. I want another sample, right? In other words, I want another sample of strontium 90, which has the same name, same half-life, but a different mass, right? Say that I wanted a mass of 20.5 kilograms instead, right? Okay. So what I'd have to do is I'd have to create another isotope, sample B, we'll say, is equal to new isotope. Now, I'm going to have to pass in the other values that are already stored in this other isotope. Isotope A, if you want to call it that, dot get name. Isotope A dot get half-life or mass, what's the order? Looks like mass and then half-life. So the mass is going to be 20.5 now because I wanted to change the mass. Okay. Remember, I can't just go ahead and reset it because I decided that I like immutable objects and that I don't have a setter function. So I'm going to have to create a new one. I've essentially ripped open the guts of that isotope, that class, pulled out two of these values, and thrown them into another constructor. There's a better way of doing that, called what's called a copy constructor. Right? Public isotope, that's a constructor, but this constructor is going to take another isotope. Right? Isotope. You could call it that. For now, let's call it that. We'll rename it better later on. And a mass. And what I'm going to go do is I'm going to say that this name is equal to that dot name. I'm copying over. It's a copy constructor. I'm going to copy over that name. This dot half-life is equal to that dot half-life. But this dot mass, I'm not going to copy over the mass because I'm passing this in right here. Okay. I will document this because it's a copy constructor. Copy constructor that copies the given isotope, but with the new specified mass. Right? And you want to get fancy, you can code mass, code, right? There. Now that is a terrible variable name. Right click, refactor, rename, isotope. There we go. And this is a reminder of this is why we follow conventions. The class name is upper camel cased. The variable names are lower camel cased. So it's really obvious which one is which here. Right? Yeah.
So why wouldn't you just use your already made isotope initializer?
This one? Oh, okay, good point. Well, inside here is what you're talking about. So let's clean that up. This isotope.name, mass, and then finally isotope half-life. Right? That's another improvement. Right? Don't repeat yourself. Right? And over here, what does my new constructor look like? It's just isotope and then the new mass. Right? Much easier, much simpler. Right? I am offloading the responsibility of making those copies to the isotope class because it's an isotope thing. Where does it belong? Isotope class. Right? Just keep repeating that over and over. And I did say that we probably want to call this sample A. So once again, right click, refactor, rename, sample A. Sample A, there we go. And it's changed everywhere for us. Right? IDE tricks, use them. Right? So there are better patterns, a copy pattern. Another better pattern is going to be it's a builder pattern. Right? Pattern, right? See the optional or advanced activities in lab 4 next week, right? So if you want to check out what a builder pattern is like, actually, we've got enough time. I can tell you why you would want a builder pattern. We're not expecting that in any of your code, okay? But a reason why you would want a builder pattern, right? Let me go ahead and create another isotope here, right? Sample C is equal to new isotope. What was the order again? I think it was the name, right? So, okay, don't tell me. I'm playing dumb right now. The name was, give me another isotope.
Uranium.
Uranium 238. All right, 238, there we go. And I want, say, I don't know, 10 kilograms of it, and its half-life is like 2.1 billion years. So E to the 9, something like that. Right? Or is it 235 that has a long, 235 has a long half-life? I forget which one is which, right? But it's like 4 billion years is its half-life. That's why we still have uranium, right? The universe is not old enough to have eliminated it, like say strontium. There's no natural strontium in the universe because the universe is too old, right? Was that the correct order though? Was it mass half-life or was it half-life mass? I don't remember. Is there anything to tell me other than going to the class and seeing what the actual order was, that it's mass half-life? Right? So apparently I was right the first time. Right? Nope. So what you can do is you can set up what's called a builder pattern. I would want something like this instead. Isotope sample D, right, is equal to new isotope builder, right, dot name uranium 238. Ooh. Dot mass 10 dot half-life 4.2 billion years. That's a billion, right? I think it's a billion. Why isn't it warning to me about overflow then? Oh, because it's a double. We're good. Right. There we go. Isotope builder. Do you see how now that's obvious? Right. Dot name. Dot mass. Dot half-life. They're all kind of named. Some languages support what are called named parameters. Python is one of them, by the way. In Python, you can say, oh, I forget the order. I don't care about the order. So book B is equal to, book B. B is equal to new book. And then you can say title is equal to foo. What else was there? Publisher is equal to bar, et cetera, et cetera. You can do, this is Python right here. This is not C, this is not Java, right? But you can do something like this so that you can put them out of order, right? You don't care about the order. And it's named, they're named parameters. So you have an explicit assignment of the title to this thing. Java doesn't have named parameters. So as a solution, we have a builder pattern, okay? We'd actually have two classes. We'd have the isotope class and this isotope builder class over here that has all of the machinery that would have all of this stuff here to be able to support that. And then what you would have at the end is .build. Right? And then it would end up building an isotope for you out of those pieces of data. Right? Again, you'd have to actually write this, right? But if you want to, go ahead and check out advanced activities in Lab 4 for it. Right? Otherwise, I'm going to leave this as is right now. Okay. Any questions? Hopefully everybody is good for assignment 0. Remember, the last help hours are today at like 4 o'clock or maybe 5 o'clock. Check. But otherwise, on Monday we'll come back with some folks coming over from the UNL Writing Center. We'll talk about the Writing Center, but we'll more importantly we'll talk about technical writing, and then we'll talk about your design document, which is due a week from today. Okay. All right. Have a good weekend.